One more day. That's page 19 in your packet. Okay, so today we're going to be doing algebraically how to solve a system of equations of 3 by 3 using the elimination method. So do one or two of those, and then we'll move on to how matrices can help solve a lot faster, and also using the calculator. But first, we're going to do a review of our algebraic steps. So page 19. Okay, so when you're solving a 3-variable system of equation, you have 3 equations, but we're still going to use the previous method of the 2-variable system. So we want to basically eliminate one of the variables so that we're down to 2, so that it'll feel more like a 2-variable system of equation. So let me start off by naming each of these equations here. So I'll call this equation 1, equation 2, and equation 3. Okay. Now we can always try to eliminate any of the 3 variables, either the x, the y, or the z. So it looks like the x's and the z's will be the easiest to do, because for the 2 and 3 with the y's, we have to make changes for both of these numbers to get to 6. But if I can target the x's, I'm going to do 2 at a time. So it looks like the negative 4x and x will be easy to get a pair up by just changing one of the coefficients. And I can also pair up the negative 6x and x, and that should be easy to eliminate. I can also go after the z's, maybe pair the 4 and 2, and then pair the 2 and the 6. But just for just so that we can stay together, let's just target the x's. Okay. So I'm going to target the first and third equation, because the negative 4x and x, I can just change one of them to get the 4x and x to cancel out. Okay, so I'm going to target the first and third. So I'm going to copy those, the first and third, down. Okay, so I'm going to target the x's. What can I multiply the bottom by to get those x's to the opposite? Yep. So if I multiply by 4, I can get the negative 4x and 4x to go away. So I'm going to recopy everything here. Just going to distribute the 4 through the second equation. Okay. All right. So now I'm just going to add up all the like variables, and I'm hoping the x's go away, and they do. And then I've gotten it down to 2 variables, which is what I want. Okay, so I'm gonna come back to this, but I've achieved my first goal, which is getting my 2 equations down to just 2 variables. Okay, so now I'm going to need to target another different pair of equations, and again, I'm still targeting the x's. So I've done the first and third. Now I'm going to target the second and third. Okay, now I could do the first and second. It's just that then I have to find a different value for the x to go away, right? I would have to change both of these to be 12. But if I could just reduce the amount of work I have to do. It just makes it a little bit easier. So I'll target the second and third equation. Okay, so what can I do to one of the equations to get the x's to match up? Second one by 6, yep, okay. The x's, we want the x to go away. Okay, any questions so far? So now we're down to a two variable equation or systems of equation. And now we're going to pair these up to see what we can do to get this down to just one variable. Okay, so we have. So I'm going to put these two on top of one another. So looks like maybe it's easier to target the y's, looking for something that both 16 and 10 can go into. And the smallest number is going to be 80. So if we can figure out what we can multiply both by so that we can get one to be a positive 80 and the other one to be a negative 80. Let's say I choose to multiply the top one by -8. That way I can target that y to be a positive 80. And the bottom one I'll multiply by 5. 5 times -16 is -80. So I have a positive 80 and negative 80. That's great. I can get it down to just solving for z. Okay, so distribute the coefficients through. Okay, so piece by piece, we're eliminating more and more variables until we're all the way down to just one variable. Once we're down to one variable, then we can solve. Okay, so -160 plus 30 is -30z. -630 plus 480 is -150. Okay. To solve for z, we can do what? Divide by so z equals 5. Okay, so once you can solve for one variable, then piece by piece, we can get it down to that, well, kind of get that domino effect to fall. So once I can solve for z, I'm now going to target the equations that have just y and z in it. I don't want to target the first ones just yet because I have still too many missing variables. But here I can choose one of these to solve for what? Y. Yeah, either one will work. I'm just going to target this one here. This looks like a smaller set of numbers. So I get y equals -4. And now I can use what to solve for x?
one of the original ones, right? Does it matter which one? No, it doesn't matter, right? So you can just arbitrarily choose which one you want to plug in. Maybe the first or third one, because it looks like they have the smallest numbers involved. So I'm going to choose to plug in the third one, but any of those will work. So replace the z with 5, replace y with -4, and then you can solve for x. So x minus 18 equals -16. Add 18 to both sides, x equals 2. Okay, so this is a ordered, not an ordered pair, but an ordered triple. So x, y, z, that ordered triple will be 2, -4, 5. Okay, any questions with the procedure? Okay, we'll come back and do number 2 for classwork, but I want to show the calculator. We're using matrices to solve using inverse. Okay. Any questions with one?
So when we have kind of get bigger numbers, will we allowed to just enter that in really quickly to calculate that?
Yes, yeah. You may see a problem where you have to show the work using elimination method, but then you're also going to definitely get problems where you have to just use the calculator and just to use inverse, which will go a lot faster. That's right. Okay. All right, so we'll come back and we'll do number 2, but any questions so far?
Yeah, like a couple of it. You just try to find like the least common, like old school.
Right, these on okay now. What you could also do is you could also multiply the top one by -16 and the bottom one by 10. That could always work. It doesn't have to be a least common multiple, it just would make it a little bit easier to work with if you're doing smaller numbers. Okay. But, you know, as long as you get those numbers to match, it'll work out. Okay. All right, let's go to page 20, and let me talk about the calculator method, which is very similar to what we do with the 2x2. Okay. So remember how we took a system of equation and we created 3 matrices, a coefficient matrix, a variable matrix, and a constant matrix. Same idea here. It's just that you have to be careful that you want to make sure that your x, y's, and z's are lined up nicely. X, y's, and z's are together on the same side, and the coefficient is on the same side as well. Now, one of these is slightly out of order. Do you see which one it is? That third one. So we have to arrange them nicely. If they're not lined up, if we put them in as it is, it's not going to quite get it in the right form. So I'm going to rewrite all the equations just so I can have everything lined up. And if I don't see a variable represented, I can always put a what for that? A 0. So I'm going to put a 0x plus 6y minus 5z equals -6. Okay. And the third one, I want the 3x over on the left side. I want the 2y over on the left side, and I want that 5 over on the right side. So 3x minus 2y plus 6z equals -5. Okay, so a lot of rearranging with that third equation. Make sure that you're comfortable with what we just did. So we want the x's first, then the y's, then the z's, then the equal sign, and then the constant. Yes.
Why can't you just move 6Z to the other side? Let's keep 5. And just switch the with you.
So if we want to use matrices to solve, we want it to look like this. We want all the x's together, the y's together, the z's together, and the constants together. So what was your question again?
Like, on the last equation, why can't you just subtract 6Z and move it to the other side?
Because if 6z is on the other side, then it's not lined up with the other z's on the other equation, right?
I thought you could just switch it.
So what's the equation that you have? What did you have?
Negative 3x plus 2y minus 6z equals 5.
Okay, the reason why it's not minus 6z is because 6z is already on the left side. So there's no need for us to change the sign of 6z. If 6z was on the other side, then I would move it to the left side and change the sign. Yeah. Okay, are we good with this? Okay. So now let's create, let's put this into matrices form. So the coefficient matrix is just all the numbers that you see. We'll create a 3x3 matrix. Okay, very similar to what we did with the 2x2, with a a system of equation with only 2 variables, but now we have 3 variables here. So x, y, and z is what we're solving for. And then equals. Okay, any questions with the setup? So I want to solve for this variable matrix, which means I have to move this 3x3 matrix. So if I want to move it, I'm going to turn it into the what? Into the inverse, and it's going to come first. Okay, so it looks like this here. X, Y, Z equals the inverse. Make sure you put that notation to remind yourself that this is not the matrix you're going to multiply by. You're going to get the inverse of this matrix, then multiply it by this constant matrix. Okay. So let me show the steps for both calculators. Okay, first, everybody okay with this, with that setup? Okay, so we're going to create a 3x3 matrix. Call this matrix A, and I'll do the inverse of matrix A. Yes. Yeah. And then multiply by that second matrix. Okay. So let me show the steps for both calculators. Okay, so from the home screen, you're going to go to matrix, edit. Same thing over here, matrix, edit. I want that first matrix to be a 3x3 matrix. So matrix A, let's edit matrix A. For your 36 Pro, you're going to have to kind of scroll down and select the correct row and column. For the 36 Pro, or for the graphing calculator, you just have to enter in the dimension that you want, 3x3. Okay, go ahead and click OK on your 36 Pro, and then just start entering your 3x3 matrix. Okay, once you're done, second mode will get you back to your home screen. Go back to matrix again. Edit. Now you want to edit your second matrix, your constant matrix, which is going to be a 3x1. Again, if it's not showing 3x1, it's okay. You can always specify the dimension of your matrix.
How do you go back?
Second mode, or second mode, yeah. So these two buttons, I'll take you back to your home screen, which you'll see that quit button. Once you're done with both matrices, now we're ready to call it and find the answer and create that multiplication relationship. So go to your matrix screen. And now we're not going to edit anymore. We're going to go to name. So call matrix A. Now on the graphing calculator, it's a little quicker. You can get to that inverse a lot faster. That x to -1 is your inverse. On the 36 Pro, you're going to have to go to matrix and you have to go to math and you have to go to that third option, inverse. So scroll down to inverse. That will produce your inverse matrix A. Okay, so now we're going to call matrix B. Math. Sorry, name matrix B. Matrix B. So x equals -11, y equals 4, z equals 6.
How do you get the inverse again?
So the inverse, there's a button that has x to -1.
You press like the A first, like that. That's the ones. Like that first. Okay.
Yeah, there we go. That's your inverse.
And it works like something.
Now you're going to call matrix B and multiply that. Yes. Yeah.
Yeah. Sorry, you had to. Like, you were encouraged to show up, you don't need to. That's what you do that.
Let me come back to you, say, your classwork. Page 19. Number 2, but number 2, you're going to follow the same steps that we did for number 1. You're going to solve it by hand, use the elimination method. And then page 22, you do 3, 4, and 5. This one you'll use matrices inverse method. Or in other words, calculate. Okay. Just be careful when you get to this 3, 4, and 5, make sure you take the time to line up each of your variables nicely, right? So your x, your y, and z are all in that order on the same side of the equation, then equals, and then your constant on the other side.
So does SVB able to do this like either way, or will it be like?
It'll be very specific. It'll be do this one using elimination method, do this one using matrices.
Calculator for the elimination method.
You can use it to double check your answer, yeah. But for now, yeah, but I want to see your work and your steps for the elimination method. Three negative opposites, yeah. So let's change the. The same. There we go. Guys, for number two, you can choose whichever variable you want, but I targeted the y's. Because I saw 2, 1, and 2, and it just felt like it's easy to get those paired up nicely. But really, any of the 3 variables can work. It's just if you want to match with my work, I targeted the y's. Let me know if you're stuck on any of the steps. I have to solve for Z. That can get complex. Z.
actually, if I can understand. I just think so.
What did you target first?
I just did fine. Or no, I targeted X.
Okay, okay, so you got the X to cancel out.
Yeah.
Okay, that's fine. So, you found Y and Z, so now you can put these back into one of the original equations and so we solve that. Yeah. Okay, so on page 22, the matrices inverse method, I have the answers on the board, so if you're able to put it in your calculator correctly, you should be get those answers. If not, let me know. I'll do that. Search. Which one? Oh, we're gonna double check. Yeah. Yeah, it's just, it's there's. Maybe with them. I thought it was probably. Also like that. They don't know something. Please second. Oh. So this is taking those mostly. The word was right. Yeah.
That happens, it's just.
There's a
solution, right?
So now I'm going to the over. So there's. We got C equals 6. Oh, I got C equals -2. Wait. Which one you target? You target the ones. Nice. Minus, I got -14.
did the first two.
Yeah.
That's fine.
Just make it different for sleep. Negative. That's it. Yeah, it's perfect. Are we not to enter just that?
Oh, you think page 20. Oh, yeah, this ends up being a no solution.
Same page.
Oh,
Yeah, so that's not, it goes in the solution, but just pages. Could also, do your determinant at the end, so your determinant ends up being a 0. It's also a solution. Always know what's right, it's usually that's because determinant. I think you guys are in a good place. You can hang tight for another 5 minutes. I'll let you guys get to your phones in 5 minutes.